Okay, is screen visible to all? Okay, good afternoon to all. So, last lecture, I think we have started steam condensers as a unit of second section for the learning purpose. So, already we have defined steam condensers. So, what is steam condenser? Anybody of you? So steam condenser is nothing but it is a closed vessel, or it is acting as one of the heat exchanger in which steam is condensed to form a liquid. Okay, and it is condensed with the help of a cooling water, which is we can take at atmospheric temperature. So from the atmosphere we can take the cooling water, and that cooling water will cool the steam coming from the turbine, and that steam we call it as a exhaust steam. That exhaust steam we are converting into liquid water. So steam condenser. So we know that by the Carnot cycle definition, here efficiency of Carnot cycle or a vapor power cycle is a function of two temperatures. So one is heat addition temperature and one is heat reduction temperature. So if 1 upon T2 minus T1, so this 1 minus this ratio to have less, so T2 is heat rejection temperature, it is in condenser, and T1 is heat addition temperature in boiler. So if heat addition temperature increases and heat rejection temperature decreases, so by reduce temperature of heat reduction, we can get more and more efficiency. And T2 represents temperature of steam, hence pressure of condenser should be less than atmospheric because vacuum. And we at vacuum, here pressure is saturation pressure is P sat is here. We in second chapter we have learned that saturation temperature is directly proportional to saturation temperature. Means to have this T2 saturation temperature means at this temperature phase change occurs, and so this temperature should be as less as possible, and to have this temperature to be very less, the saturation pressure should be less. And this saturation pressure, if condenser would not be there, then only we can reduce the saturation temperature up to atmospheric condition. But due to use of condenser, the saturation pressure we can decrease less than atmospheric pressure. And due to that, your saturation temperature also can be decreased. So less than atmospheric means negative pressure, or we can say this pressure as a vacuum pressure. Okay, so to create the vacuum for the condensation, the condenser is very much important. And due to this condenser, efficiency of cycle increases. This is the one of the advantages of the condenser. So efficiency of cycle or efficiency of plant, we can here due to condenser efficiency of plant, definitely it will get increased. Efficiency increases due to use of condenser. Everybody getting this point? How efficiency will increase due to condenser? If condenser would not be there, no problem. But what efficiency of that plant will be very less. Everybody understand this point? So because heat rejection temperature should be as less as possible. Also, another criteria is there that condenser pressure is also here in Rankine cycle efficiency. Condenser pressure is here. Anybody is inversely proportional to eta Rankine. Okay, so I will write R only. So therefore, if condenser pressure is too much less, then also efficiency will be more. And means heat rejection temperature or condenser pressure should be as low as possible. And for that, condensers are very much important. Anybody understand this? Please chat. Please mention in chat box. Or you can write also. Yes, sir, understood. Asmita only understanding. Prerna and Asmita. Others, please reply. Okay. So, So a condenser in which steam condensed by extracting the heat and where the pressure is maintained below atmospheric, and that is known as condenser. So vacuum is required. Vacuum is means we are maintaining vacuum because to decrease the pressure and to have the more efficiency, or to decrease the here to decrease the heat rejection temperature. Then elements of steam condensing plant. So which are the different elements of steam condensing plant? So before that one, okay. So these are the elements of steam condensing plant. So I think here these are very good diagram schematic. So this is very important diagram for these are the elements of steam condensing plant. So which are different elements of steam condensing plant? So this is one is the condenser. Okay. Then from condenser, as inside the condenser, there is a vacuum. Air pressure is very less than atmospheric pressure. So what are the exhaust steam? So this is called as what? Exhaust steam. So this is whatever the steam is coming from turbine is called as what? Exhaust steam. So remember, exhaust steam is what? The steam is exhausted from by the turbine. After doing that work, whatever steam is remained having low pressure, low temperature. So that steam we call it as a exhaust steam. Okay. And so this exhaust steam is there passed to the condenser. So here from the river or one cooling tower, here this is the cooling tower pumps, cooling tower is there or river is there. From this we can take the water, cooling water, condensing cooling water pump. So this pump will fetch the water to this particular condenser. So one line is of coming off what exhausting, and one line is coming off that particular cooling water. So this cooling water will take this heat from this particular exhaust steam, and this steam will get condensed. And this condensate is there because some pressure is less than atmospheric pressure. Therefore, we need to take out that particular steam here with the help of this condensate extraction pump. And so therefore, one pump is used, condensate extraction pump. So this condensate extraction pump will extract the condensate from this particular condensate and supply it to the one well. It is called as hot well. Why hot well? Because whatever the condensate is we are storing or we are taking inside this particular well. Okay, so this is having temperature. So this water is having temperature more than atmospheric water, and therefore this is called as hot well. This is nothing but what? This will be hot well. And this afterwards this pump, this feed water is having more temperature, and with the help of boiler feed pump, this water is again recirculated back to the boiler. So why it happen? Because if we will supply atmospheric water to this particular boiler, its temperature is less, and here hence more heat is required in boiler to heat it again. But as this water is much more water than atmospheric water, so due to this supply of this water, here less heat is required into the boiler. So this it will save also the boiler efficiency. And if the boiler efficiency is get saved, overall efficiency of plant will also get increased. So then this steam is generated, it's supplied to a turbine. Afterwards, we are generating some amount of work. Okay, also we can show like this here. The work is generated and remaining steam is exhausted into condenser. So again, and what will happen? Then this cooling water will get heated because it has absorbed the heat from the steam, and due to that, this cooling water is get heated. Again, supplied to the river. Okay, and this it will get mixed with river and it will get cooled. Or some when this is happening, when there is a source of water is available in abundant amount, much more amount of source here. If the water is available in much more quantity. So in that case, this is happening. But when less amount of water is available, then this water is going to be supplied to the cooling tower, and these cooling towers are there. This cooling tower, such kind of cooling towers are there. And so this cooling tower, what will happen? So this water is supplied, water coming from this particular condenser is again here sprayed from this more height, and it will get contact with the air. So air is there in this case. So this air is moving in the upward direction, and as area is less here, velocity of air will be more, and due to that, this water will get cooled. This cooled water is again reused into the condenser. So this is called as what? Cooling tower. I will show next slides PPT where we have used the cooling tower. So this river can be used when water source available is much more water available. We are not caring about water. Source of water is available. So in that case, river water we can directly, and we can apply after use. We can here uh, let we allow that water to get out from the plant, no problem. But when source of water is available in much less quantity, then we have to recirculate that water, and for that these cooling towers are used. Okay, and this condensed extraction pump, hot well, where we are storing this particular condensate. Now here we know that here from this particular turbine, some air will come into this particular condenser. So from this cooling water river, with some that particular cooling water, some air will also come into this particular condenser. So if air is coming, then definitely pressure will be atmospheric pressure. So, and we want less than atmospheric pressure. So we don't want air inside this condenser, and therefore whatever the air is coming into this particular condenser is maybe with the steam, exhaust steam, maybe with this cooling water. So this air we want to remove at time to time, and for that here we are using this air pump. What is the function of air pump? This is the reciprocating pump, and whatever the air is coming into the condenser, entering into the condenser, it is continuously removed with the help of this air pump. And so when air will remove, definitely vacuum is going to be generated. Vacuum means no air condition. So remember that vacuum is negative pressure means what? Again, somewhere if you want to write here, you write down vacuum is what? No air present. No air, or in absence of air, no air. So this is nothing but what? Air pump is there. So what are the elements? I will now go back to this. What are the elements of condenser? Is condenser cooling water pump, and mega water pump. So mega water pump means how much, some amount of steam may be exhausted. Here it is going to be here exhausted, or let it is due to leakage, some amount of steam is leaked. So that amount of water, that amount of steam equivalent to that water amount, we have to make up water, we have to use. Otherwise, other water, the water we have to reuse again and again. So condensate extraction pump, as there is a vacuum inside the condenser, pressure is less than the atmospheric pressure. So to remove that condensate, naturally the condensate will not come out from condensate, and here for that, to force out this condensate, we have to use the condensate extraction in hot well to store that particular condensate in that particular, and to supply this to boiler. So we are storing this condensate into a well or storage, that is called, we call it as a hot well. Then boiler feed pump. So with the help of this boiler feed pump, whatever the condensate we have stored in the hot well, this we are supplying to the boiler. Air extraction pump to remove the air bubble, air coming entered into the condenser, maybe with steam, exhaust steam, or maybe with the cooling water from the cooling tower or river. So air may be enter, there are chances, and some, because of some, there are also some joints are there for condenser. If some joints are weak, or there are not air tight, air proof, then some amount of air may enter into the condenser, and that air we have to remove with the help of this air extraction. And cooling tower is there. Here it is going to be when amount of air, here it is there. So when amount of water available is less quantity, then we have to use cooling tower. So when cooling tower is will be in picture, then what will be the picture? So everything will be remains same up to this. Here, only thing is there that when river less water is available, then in that case, here we have to use this particular cooling tower. So this cooling from this water cooling condensed cooling water pump, this water is going to be taken this with the to the condenser and some amount of makeup water from river. So river pump, makeup water pump is there, condensed cooling water pump is there, and this water we have to supply to condenser. The steam will coming in this direction, okay, and in this case, this steam's heat from steam is taken from this water, and this water will get heated. This heated water we want to reuse again and again. So this water we have to supply to the cooling tower. So what is cooling tower? So it is from one height. This is maintained at much more height. Okay, and this cooling water is going to be sprayed into this particular cooling tower. Okay, and where it is in comes in contact with the air. Okay, so there are afterwards we are going to learn cooling towers types are there. Forced draft means we're using the fans so that air will maximally it will cool this particular water, and this cooled water is get here is taken or it is stored at the bottom side, bottom reservoir, bottom of the cooling tower, and again this is reused again and again. Whatever the steam is exhausted or less water, well, whatever the water is get deficient, this water, deficient water is here taken from this river with the help of this makeup water pump. And then other cycle is going to be same. So this is when less amount of water is available nearby industry, and cooling towers is use of cooling tower is compulsory. And when abundant amount of water is available, so more water is available, then here we have to use river direct. In this case, cooling tower we can neglect. These are the elements of steam condensing plant. Anybody have doubt about this? Anybody having doubt? Any questions? Understood clearly? This is very theoretical only. Anybody? Clearly, I want more reply. No doubt, sir. Understood. Very good, Asmita. Others, please reply. Prerna and Asmita only understanding. Others, I think 25 students are there in class. Only these two girl students are understanding. Others, please reply. And I request to draw Vishal Metkari. Thank you, Vishal. Others, please reply and draw this diagram immediately. I will give 5 minutes to you. So first of all, write down these elements of condensing plant. Hartley. Then draw this figure. I will give 5 minutes to you. This diagram is over. Over. Please reply. This diagram, somebody can reply, Smita. So whether you learned this diagram in BME, basic mechanical engineering, last year. Okay. No, no. I think the previous syllabus, this was there, I think, in BME. After this, only a meter diagram is over. Others, please write, draw it fast. So drawing is not important, but only understanding each and every component function is very much important. Or only a Smita diagram is over. Others, please reply. So other chapters are very, very small chapters. Okay. Tomorrow we can complete the classification of condensers and we can complete this chapter also. So okay, draw this diagram also. Is diagram over? Okay, I will supply notes. So, now, advantage of condenser, we have discussed about that. As pressure is decreased, then efficiency will also go on increasing. So, plant efficiency increases due to increased expansion ratio. That is, now instead of going for say, 10 bar boiler pressure steam to 1 bar of condenser pressure, instead of that, if you go for 73 mm of edge of vacuum, it's less than at 1 bar is the atmospheric pressure. But before here, less than say here that also 73 centimeter of Hg means here if we are having 76 centimeter of Hg means 1 atmosphere. So instead of that, if we go for 73 means less than atmospheric pressure, then enthalpy drop, this will be H1 2778 minus H2 2400. So this will become 378. Then instead of that, if the pressure will become 173 centimeter of vacuum, okay, the 76 means 1 atmosphere. So instead of that, if it will become 73 less than atmosphere decreased, then enthalpy drop will become 2778 is there here minus here 1995. So if you go for this 1995, so this will become 783. So it's this 783 kilojoule per kg. This will be the enthalpy drop, and this enthalpy drop will mean what? More kinetic energy, because here kinetic energy is nothing but what we know, that C2 is equal to what? Here it is directly proportional to square root of H1 minus H2. Okay, 44.72 is one of the constant we can say into there. Means enthalpy drop is more, means kinetic energy is going to be more. And if input is more, work obtained will be more, or efficiency will be more. So due to here decrease in pressure, increased expansion ratio. You see, in decreased pressure means increased expansion ratio. Efficiency of the cycle will increase. The here this is one of the reason that condenser. Then heat, another advantage is heat to be supplied to the boiler is reduced due to increased temperature of feed water. So don't give attendance, Sesh. So due to heat to be supplied in the boiler is reduced due to increased temperature of feed water, that is condensate. And cost of power generation reduces due to availability of pure feed water by condenser. Because if we supply the, so there I have told you, so because more temperature feed water if you supply into the boiler, definitely less amount of fuel is required. Then less amount of fuel required means it will increase the efficiency of boiler. And if efficiency of boiler increases, overall efficiency of plant will also increases. Other advantage will be what? Cost of power generation reduces due to availability of pure feed water by condenser. Because here there is no what we can call treatment. Water treatment means if the atmospheric water we are directly using into the condenser, then in that case some corrosion and erosion to the pipes. Okay, pipes inside our tubes inside the boiler will be condenser will be get corroded, or their wear will happen fastly, and that will be the cost will increase, maintenance will increase. Boiler corrosion is prevented due to availability of pure free water. If it is pure free water, and condensed water is always pure, I told you. Okay. Now here, before going to this slide, we'll go to another presentation so that we will. From this we put some another point. But condensation can be done by removing heat. Yesterday we have discussed about this function to reduce the turbine exhaust pressure so as to increase the specific output and hence increase the plant efficiency. Then to condense the exhaust steam from the turbine and reuse it as pure feed water. An advantage here we are getting high compression ratio provides larger enthalpy drop. So we have seen this here. We have taken example of 10 bar and 1 bar, and 10 bar to 1 bar it is set 383 kilojoule per kg of enthalpy drop we are getting. Now work output per kg of steam increases and hence specific steam consumption decreases. Condensate can be reused as a hot feed water to the boiler. This reduces the time of evaporation and fuel economy. These are one of the advantages. No feed water treatment is required and hence reduces the cost of the plant. And formation of the deposits in the boiler surface can be prevented with the use of condensate instead of feed water from other surface. So deposition in boiler, etc., corrosion will be less. Then elements we have discussed. These are the elements. Now, I think we have discussed also on that day, but due to electricity problem, we could not continue the lecture in continuation. So there are two types of condensers are there. One is mixing type of condenser, and another is what? Here, surface condensers or non-mixing type of condenser. So jet condenser. Now on that day I have defined. Anybody of you can define jet condenser? Anybody? Jet condenser. Anybody of you can define? Jet condenser means what? Anybody of you? Jet condensers. Nobody will define. So there are two types of streams are there in the condenser. One is of what? Cold water, cooling water coming from the cooling tower or river. And another is what? Exhaust steam coming from the turbine. So jet type of condenser, or it is called as mixing type of condenser, in which cooling water as well as the exhaust steam from condenser get mixed with each other. So that type of condensers are called as what? Jet condensers. Everybody getting? So it is a very simple type of condenser in which cooling water is coming from the cooling tower or maybe directly from river, depending on that water availability. And one stream is coming of steam, exhaust steam. So both will get mixed with each other. If the steam will get mixed with water, definitely it will get condensed here, condensate will form. And another type of condensers are there were non-mixing type. So in this case, cooling water is coming in the form of tubes also. Okay, and steam may flowing above these particular cooling tubes or vice versa. And but they directly doesn't mix with each other, but only transfer the heat with each other, and they can here transferring the heat and it may condense the steam. So that type of condensers are called as surface condenser. Surface condenser means what? It is called as non-mixing type of condensers. Here we are having example. So jet condenser versus surface condenser. So jet condenser versus surface condenser. Jet condensers means it is direct contact type or mixed type condenser. Direct because there is direct contact. So here we can see here exhaust steam is coming from this particular turbine, and this is cooling water from this particular cooling tower or river, and they are directly mixed with each other. And this is condensate, is nothing but a mixture of this exhaust steam and cooling water. So directly it is get here condensed, and this is condensate. So this condensate is nothing but what? Cooling water plus condensed steam. Okay. Here this is called as what? J type of condenser. It is nothing but what? Which type of condenser? J type of condenser. Okay. And another type of condenser is nothing but what? Surface condenser. What is surface condenser? Surface condenser is nothing but here there is no mixing of the cooling water and exhaust steam. So this is cooling water is coming here This cooling water is coming in the form of tubes, in the form of pipe or tubes. It is circulated like this, okay, and it is going out through the tubes. Okay, so there is an exhaust steam is coming from the top direction. Here it is from the top direction, exhaust steam is coming. So it is flowing around these tubes, okay, and this heat transfer, this cooling water will take the heat from this exhaust steam, and this, and again bypass, there are many passes of this cooling water, and this exhaust steam is coming in contact with this cooling water, but not directly. So it will take the heat, and when it will take give the heat, and condensation will happen. This condensation is what, at the bottom, this condensation takes place, and this condensate is here removed, or it is taken at the bottom side. Here in this type of condenser, there is no mixing of cooling water and air steam. This condensate is very very pure. This condensate is very very pure, but this condensate is what, mixed with what, cooling water. So this may not be that much pure, but this cooling condensate is very much pure, because there is no mixing of cooling water, and this cooling water we are taking to the what, cooling tower for reuse purpose. Everybody understand? So this is called an indirect type or non-mixing type of condenser, or it is called a direct contact or mixed type condenser. So jet condenser and surface condenser, everybody got difference clearly? Anybody having doubt about this? Anybody having doubt about the understanding problem? Anything? Please reply fast. Asmita, yes sir, got it. Others please reply. Only Asmita, Prerna, no doubt. Others are, please reply so that we can move to the next article. So if you are giving interaction in good manner, then definitely we can complete syllabus as early as possible. Now there is no question of completion of syllabus because we are ahead. Ahead, na? Other than others syllabus. Because that's why my speed I have decreased intentionally. Asmit or Prerna, you can reply, we are ahead or we are lagging. If you are lagging, then we can increase syllabus. I will, sometimes I'm intentionally here giving some tests quiz ahead. Okay, good. Thank you, Asmit. Okay, now we'll just revise, and then tomorrow we'll go in detail. So there is difference. Many times they may ask the difference between comparison of jet and surface condensers. So what is first point? So there is nothing to explain the first point. Jet condenser, cooling water and steam are get mixed up. So cooling water and steam mixed with each other. So that is nothing but your jet condenser. And here in the surface condenser, this cooling water and your steam aren't they doesn't mix with each other. It is very very simple type of condenser. It is having what, low manufacturing cost, because there is only one vessel in which we have to mix both. We have to both pipelines. We have to drop in only one vessel where steam will get come and water will come and they will get mixed with each other. So there is low manufacturing cost. Here it is we have to go for tubing for water, then casing, shell we have to go for. This is a shell and tube type of condenser, surface condenser. Therefore, high manufacturing cost. Then requires small floor space, because why? Because it is direct mixing. Therefore, there is no loss of heat, and here it requires more larger space because efficiency is less surface condenser because it is indirect contact. Here it is direct contact. So here requires small floor space. And the condensate, now the condensate is not pure because it is mixed with cooling water. Therefore, the condensate cannot be used as feed water to boiler unless it is free from impurities. So therefore, condensate, if you want to condensate to be used up in boiler, then we have to reuse, we have to make water treatment for that because it contains impurities of cooling water. So cooling water is not a pure water. But here, the condensate can be used as feed water to boiler as it is not mixed with cooling water. But here it is mixed with cooling water, therefore it may contain some impurities, and therefore we have to use this water treatment is required. Then more power is required for air pump. because it is containing more air, because directly it is mixing, therefore air pump power is going to be required more. Here less air pump power is required because it is not, cooling water is not directly mixing with the steam. Then less power required for water pump. So less, because water pump is what, less power is required for water pump and more power is required for water pump, because here directly water is available in this particular vessel, therefore there is nothing, water can be stored, therefore less power is required. But here continuously water should be moved from one place, from these tubes. Okay, therefore more water, more power is going to be required. पाण्यातून काय ट्यूब मधून पाणी भरपूर वेळा आपल्याला सर्क्युलेट करावं लागते, त्यामुळे मोर पॉवर ऑफ वॉटर पंप इज रिक्वायर्ड बट लेस पॉवर ऑफ एअर पंप. Require less quantity of cooling water because it is having more efficiency. Directly water is get mixed with steam, less quantity of cooling water is required. Here requires large quantity of cooling water. Larger quantity because efficiency is less, because indirect type of contactor, less suitable for high capacity plant due to low vacuum. कारण त्याच्यामध्ये व्हॅक्यूम कमी आहे, बट इट इज कंडेन्सिंग प्लांट इज कॉम्प्लिकेटेड, सिंपल असेल, कॉम्प्लिकेटेड आहे, सिंपल आहे, and it is here more suitable for high capacity plant as vacuum efficiency is high, because air ह्याच्यामध्ये जास्त मिक्स होते, ह्याच्यामध्ये कमी होते, त्यामुळे vacuum efficiency चांगली आहे, ह्याची vacuum efficiency is going to be less and lower upkeep. ह्याला काय जास्त काळजी घ्यायची गरज नाही, बट ह्याला हायर अपकेप म्हणजे काळजी जास्त we have to take. This is the difference between this cooling jet type of surface condenser and surface air condenser, jet condenser and surface condenser. Everybody got this? So tomorrow definitely I will revise once again. Anybody having doubt, problems, chat, anybody here mention. Now tomorrow we have to go in detail. It is types of jet condenser and surface condenser. No doubt. I had okay. Asmita, others, Prerna also giving and maybe understand. Others, please reply. I want reply interaction from everybody. Vijay Bhatt, no doubt. Very good, Vijay. Thank you. Prerna understood. So with this, I think today we'll stop. Vishal also, thank you. So again, tomorrow we'll raise and tomorrow we'll go with the help of Onkar also. Thank you, Onkar. Tomorrow we'll go in details the types. Tomorrow we may finish because it is having no numerical, so here no formulae, no derivations. So tomorrow we may finish this particular chapter. Okay. Thank you.